Hello guys and welcome back to my channel. In this video I'm going to talk about sound level and noise criteria in some spaces when we want to design the system in HVAC. If you are ready, let's get into it. So the first parameter is called NC in the standard, and NC stands for noise criterion. So basically when you look at these two words, N comes from here and C from here, so that's going to be NC. And we use these NC graphs from this chart or from this diagram to determine at what level we are going to be. So for example, the lowest numbers mean the sound level is very, very low. And when you go up, the sound level is going up. The relevant parameter is usually used to measure the sound level from a specific production source, like an air conditioner, and is divided into graphs like this one in the range of 15 to 70 numbers. For this measurement, it's necessary to compare the obtained results with NC curves after determining the sound pressure level and also sound analysis in different spaces. To start the measurement, it should be studied in the middle of the place, and after observing all the points that should be observed about the sound measurement by the sound level meter, we should get the sound pressure level in the place and also the sound analysis in different frequencies. So again, if you want to look at this diagram, which is very important in HVAC, in the horizontal line, we have the octave bands from 63 Hertz to 8000 Hertz. And on the vertical line, we are getting the sound pressure level in decibel, which is dB. And again, the lowest numbers here is going to give you the lowest sound level. And when you go up, the sound level is increasing. And the most important thing here is the sound level at the lowest frequencies. So for example, at 63 Hertz and 125 Hertz, working with the sound levels are very, very important. The other numbers are important also, but not as the first two one. The other thing that you need to take a look is the duct sizes. And there are some numbers here from ASHRAE, which recommends that based on what NC number, what velocity you should have in your duct system. So these numbers are going to be very useful for you guys. So for example, if somebody asking you for NC level around 20, that means the velocity should be around 550 feet per minute or less. If we are talking about NC 25, the velocity can go up a little bit, around 700 feet per minute. For NC 30, again, 850 foot per minute, and for NC 35, around 1000 foot per minute should be acceptable. Now we want to do an example based on these numbers. For example, you are working in a studio. This is a sound recording studio, which the noise and sound is very, very important, and it should be very low because otherwise that's going to impact the production, right? So in this studio, they are asking us for NC level around 20, and the airflow is about 1500 CFM. So there you go. Based on NC 20, your velocity in the ductwork should be around 550 feet per minute. Simple formula, you can get the area of the ductwork. That means 1500 divided by 550 feet per minute. The net size of the duct is going to be 20 by 20. And if you want to add another 1-inch liner for acoustical purposes to this duct, the final dimension is going to be 22 by 22. Again, this is like a ductwork exposed in the space with no insulation, just with 1-inch liner. If you want to go with insulation, the insulation should be at least 2 inches per new IECC codes. And the final dimension for the duct is going to be at least 24 by 24. So again, this is a very quick example and simple stuff about sound level and noise criteria. We are going to talk about this stuff in the next video also. As far as different fittings in sheet metal system, please let me know what you think in the comments below, and like and share the video with your friends.